Let me firstly show you what you will be able to build by the end of this course. So as this course is all about face detection and face recognition, so firstly we are going to keep things simple and build our face recognition with images application. So this is the application which we are going to build, and it has three main features: face registration, face recognition, and managing registered faces. So let's register a new face, and for that purpose press on this button. And now on this screen user can either choose image from gallery or capture image using camera for registering a new face. So let's try that. So I will gonna open the gallery, and there let's select this Cristiano image for registration. So once we are going to select the image, our face detection model will gonna detect the face, and we will see this dialog where we can assign the name and register the face. So let's assign the name Ronaldo here, and then press register, and there you can see this message, face registered. So it means that now this face is registered inside our system. And if we go back and open this registered faces screen, there you will be able to see the list of registered faces, and you can see this Ronaldo face here as well. Similarly, I have registered some more faces here, and after registering a face inside this recognize face screen, you will be able to recognize them. So let's select an image, like we are going to select this Mr. Beast image, and there you can see we are able to recognize Mr. Beast because we got this rectangle drawn around his face, and we also got the name Mr. Beast. Similarly, let's test it for this image, and there you can see we got the name Rock here. Similarly, we can select some Cristiano image like this one, and there you can see we got the prediction or recognition Ronaldo here. And if we are going to select an image where multiple people are present, so there you can see it is able to recognize both Mr. Beast and the Rock, and even it is able to recognize this Rock image in the poster. So it means that our application will gonna perform face recognition and face detection very accurately. So this is our face recognition with images application. So after images, we are going to build our real-time face recognition application. So in this application, user will be able to register and recognize faces with the live camera footage. So let's register a new face. And once the face is captured from all the angles, he will see this face registration dialog, and there he can enter the name and register the face. And after registering the face inside our registered faces screen, he will be able to see and manage those faces. And after that, inside our recognition screen, we are going to detect and recognize that face in real time. The complete course is around 5 hours long, and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion, which you can include into your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, you can simply ask for a refund. And the best part is we are not using any paid service or API for performing face recognition and detection, but instead we are using powerful ML models in a TensorFlow-like format. And because of these models, our application will gonna work without needing any internet connection. So what are you waiting for? Join this course now and start building real-time ML-based Flutter applications. If you want to become a mobile machine learning expert, then subscribe to this channel and check out our mobile machine learning courses available on Udemy. The discounted coupons are given in the description. Welcome to this lecture. In this lecture, we are going to learn about the working of a facial recognition system. So let's start. A facial recognition system can be divided into two main parts. The first part is face registration, and the second part is face recognition. So as the name suggests, in face registration, we are registering faces inside our facial recognition system so that we can recognize them later. And in face recognition, we are going to recognize those registered faces. So it is similar to the facial recognition system of your mobile device. So there you firstly register a face and then later you can unlock your phone by using that registered face. And now let's understand the working of first part, which is face registration. So let's suppose that we got this Bill Gates image and we want to register his face inside our facial recognition system. So for that purpose, after taking this image, we are going to pass it to a facial detection model. So now a face detection model can detect the location of a face present in an image. So this model will gonna detect the location of Bill Gates' face, and using the information we can draw the rectangle around that face. And after that we can also crop the image and only get the portion where the face is present. So after getting this cropped face image, we are going to pass it to our face recognition model. So now this face recognition model will gonna generate the embedding for this face. So what is this embedding? So this embedding is actually a float array, and it is the numerical representation of this face image generated by this facial recognition model. So when we are going to pass this cropped face to our facial recognition model, it will gonna return us a float array representing this face. And this float array is called face embedding. So face embedding is a numerical representation of face image generated by face recognition model. And in face recognition, we generate and compare face embedding for faces to determine that whether they belong to same person or not. So if for two face images the embeddings are similar, then there are chances that both images belong to the same person. So that is a basic overview of embedding, that it is a float array representing that face. So after getting the embedding, we are going to show a dialog to the user, and there we will ask user to assign a name to this face. So let's say user will gonna assign the name Bill Gates and he will gonna click on register button. And upon clicking on this button, we are going to store the name which user entered here and the embedding for this face inside our database. So inside our database, we got two columns, one with the name and the second one with the name embedding. So here in the name column, we are going to store the name which user assigned, and in the embedding column, we are going to store the embedding returned by our face recognition model. And by that way, our face will be registered. So when we say that we have registered a face inside our facial recognition system or inside our mobile device, basically we are storing the face embedding returned by the model. So the whole process of face registration can be divided into four main parts. So the first part is taking the image and passing it to our face detection model to detect faces. After that, based upon the result of face detection, crop the face from the original image. And then the third step is passing those crop faces to our facial recognition model to get the face embedding. And after that, for registering the face, we will ask user to assign a name to that face, and we are going to store that name along with this embedding in the database. And by that way, our face will be registered inside our facial recognition system. So hopefully this thing is now clear for you. And now the second part of our facial recognition system is face recognition. So the process of face recognition is similar to face registration, but there are only few differences at the end. So let's understand it. So after registering the face of Bill Gates, now if we are going to show some different image of Bill Gates to our facial recognition system, then it should recognize that image. So let's say we got this image and we are passing it to our facial recognition system. So again, after passing the image, firstly it will be passed to our facial detection model and we will get the location of the face. And after that, we are going to crop that face and pass it to our facial recognition model. And now this model will gonna generate the embedding. So everything till this point is similar to face registration. But after getting the embedding in face recognition, we are going to compare the embedding of this face with the embedding of registered faces. And then we are going to calculate the difference or the distance between two embeddings. So let's say the distance between the embedding of this face and the registered face of Ronaldo is 1.56, and the distance between the embedding of this face and the registered face of Bill Gates is 0.36. So now we can see the difference between two embeddings is minimum in case of this registered Bill Gates face. So now we can infer that this crop face is actually representing Bill Gates. Or in other words, we can now show the result that Bill Gates is present in the following image. So that's how face recognition is performed inside any facial recognition system. That after getting the embedding for the face, we are comparing it with the embedding of registered faces, and where the two embeddings are similar, we are considering that registered face as our recognition. So the whole process of face recognition can also be divided into four main parts. So the first step is taking the image and passing it to the face detection model to detect faces. And after that, based upon the results, we are cropping the face. And then in the third step, we are passing that crop face to our facial recognition model and getting the embedding. And after that, in the fourth step, we are comparing the embedding of the face with the embedding of registered faces. And where the distance between two embedding is minimum, that registered face will be our recognition. So the whole process of facial recognition system can be represented with the help of this image. That in the system, when we are passing an image, firstly it will be passed through the detection model and we are going to crop the face. After that, that crop face will be passed to our facial recognition model and we will get the embedding. And after that, if we are registering the face, then we are showing a dialog and taking the name from the user. And when the user will gonna type the name, we are going to store the name and the embedding in the database and our face will be registered. And if we are recognizing it, then we are comparing this embedding with the embedding of registered faces. And where the difference or the distance between two embedding is minimum, we are considering that registered face as our prediction. So hopefully you got the idea about the working of a facial recognition system. Welcome to this lecture. In this lecture, we are going to build our first Flutter application of this course, and this is an image picker application. So basically, we are going to build an application where user can choose an image from gallery, or he can capture an image using camera inside our Flutter application. And after that, we are going to display that selected or captured image inside our Flutter application. And we are building this application because later we need to pass that image to our machine learning models and get the results. So that's why we are learning to choose or capture images inside Flutter. So now let's start by creating a new Flutter project. So open your Android Studio and click on this new Flutter project button. After that, make sure that Flutter is selected here, then click next. And here you need to assign a name to your application. So I will name it as image picker. And after that, you can select the project location here, and then you can add a description if you want to. And after that, you can select the platforms for which you want to build this application. Like here, Android, iOS, Linux, Mac, Web and Windows is selected. So it means that this Flutter project will be created for all of these platforms. So after ensuring these things, click on this create button and our new Flutter project will be created in just a second. So now our new Flutter project is created and it is ready. So let's firstly install this new application inside an iOS simulator or inside an Android emulator and look at the default counter application. And after that we are going to start building our image picker application. So I have already created an iOS emulator and you can see it here. And in your case, if it is not running, then you can click on this open iOS simulator. Then a simulator similar to this one will be opened. And after that you can select it here and then click on this run button and our application will be installed inside it in just a minute. So now our application is installed inside the simulator and you can see the starter application. So this is basically the default counter application provided by Flutter. And here when you will click on this floating button, this count will gonna increase. So this is the application present inside our starter code. And now we are going to make changes inside this code because we want to build our image picker application. And the first step of building our application is creating its GUI. So inside our image picker application, we are going to add a button on screen. And when the user will gonna click on this button, we are going to launch the gallery where user can select an image. And once user will gonna select the image, we are going to display that selected image here. Similarly, when the user will gonna long press on that button, we are going to launch the camera. And when the user will gonna capture the image in that camera, we are going to display the captured image here. So that will be the flow of our application. And now we are going to start by adding the GUI of our image picker application. So in the GUI, we will have a button and then a view where we are going to display the image. So where in this application code we need to add the button. So right now you can see we are inside our main dot and it contains all the code of this counter application. So here when you will scroll down, you will find a build method here. And inside this build method, the GUI of this application is present. So when you will scroll down, you will gonna find this text widget which is displaying this text. You have pushed the button this many times. So this is the text which is being displayed here. And then also we are displaying this count here. So here we are displaying the GUI of this counter application. But now we want to build the GUI of our image picker application. So we are going to remove the GUI of this counter application here. So basically inside our build method we got a scaffold and then in that scaffold we are displaying this app bar. And this app bar is displaying this title Flutter demo homepage. And after that in the body of this scaffold we are displaying a column widget. And that column widget is displaying both of these text widgets. But now we are going to remove both text widgets from here. And after that press Command S. And when you will do that, you can see this text is gone. And the reason is we have removed these widgets from here. Similarly, let's remove this button as well. So you can see this floating action button. So just select it till this point and then remove it. After that, press Command S. And now you can see this button is gone as well. And now after removing the previous GUI, we are going to add an elevated button here. And then in that button we are going to pass the child property. So the child of this button will be a text widget because we want to display a text choose or capture on this button. So write the text choose or capture. And after that the second thing which we need to pass is this onPress method. So this callback or this method will be executed when the user will gonna click on this button. So here we can pass an empty method. And this method will be executed once the user will gonna click on this button. So press Command S. And you can see this button choose or capture. And when the user will gonna click on it, this method will be executed. And inside it, we are going to write the code for opening the gallery so that user can select an image. And once user will gonna select the image, we need to display that image above this button. So to display that image, we are going to add an image widget inside our GUI. So write image here and then call its file method. So we are going to display the image using a file object. And the reason is once we are going to choose or capture the image, we are going to get that image in the form of file. And after that we are going to display that image using this image.file method. But right now we do not have our image in the form of file format. but later we are going to get that image in the form of file. So to store that image in a file object, what we can do is to create a file object inside our my home page state. So basically above this build method, you can declare a variable of type file and then you can name it image. And after that you need to import the library in which this file object is present. So click on this icon and import this library .io. And after that you will see an error here because we did not initialize this image object. So here we can make this image object nullable. So it means that this image variable can be null or it can contain an image file. So after creating this image variable here, we are going to pass it inside this file object. So image and select this image. And after that between these two widgets add a comma and this error will be gone. But right now you can see we are getting an error that this image can be null or the argument of file cannot be assigned to a parameter of file. So basically it is stating that we cannot specify this image variable here because it can be null. So here to avoid this thing we can check that if this image variable is null, so in that case we are not going to call this image.file function. So if this image is equal to null, so in that case we are not going to do this thing, but in that case we are going to display an image icon here. So I have added an icon widget here and inside it you can specify the icon which you want to display. And you can select this icon using this icons class. So add this icons and then add a dot and you will be able to see a lot of icons here. So as we want to display an image related icon, so type image and you will find a lot of image icons. So let's select this icon for now and after that add a colon here because this is the else block. And after doing this thing we have made sure that whenever this image variable will be null, so in that case we are not going to display the image but we are going to display the icon. So here we can pass a not null insertion that this image variable will not be null whenever this function will be called, because we have made sure that whenever this variable is null we are going to display an icon and not going to display this image. So after doing that press Command S and there you can see this small image icon here. And now we can also increase the size of this icon. So here set the size property and we are going to select the size to 50 for now. After that press Command S and you can see the size of this icon is increased. Similarly if you want to increase it further like 150 then you can do that and you can see its size is increasing. So now we have created a very simple GUI for our image picker application. And in that GUI we have added a button which is displaying this text choose or capture, and then we are displaying a view or a widget where we are going to display the image. So basically before displaying the image we are checking the value of this image variable. So if it is null, so in that case we are going to display this icon here, and if it is not null, which means that user have chosen or selected any image, so in that case we are going to display that image on screen. And now inside our next lecture we are going to start the process of choosing or capturing image inside our application. So see you in the next lecture. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Flutter and face recognition course. The complete course is around 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 50 students. And now let's continue to the next lecture. Welcome to this lecture. So now after creating the GUI of this application, it's time to add the feature of choosing or capturing images inside Flutter. So to do that, we are going to use a library called image picker. So open your favorite browser and then go to Google and here type pub.dev, and you can also directly type it here in the search bar. And now in the search result open this first link pub.dev and this website will be opened. So this is basically the official package repository for Dot and Flutter applications, and here you can search for any Dot or Flutter related library, and the library which we are looking for is called image picker. So type image picker here and press enter, and after that to view the results clearly let's minimize the simulator, and you will be able to see this image picker library as the first result, and it is the most popular and used library in Flutter. So click on this library and the documentation page will be opened. And now the first step is installing this library inside our Flutter project. So to do that, click on this installing section and there you will find this dependency. So just simply copy this line and open our application. And here inside pubspec.yaml file you need to paste this line in the dependencies section. So you can see this section here, and whatever library you want to add in your project you need to paste its dependency here. So I pasted it here, and now click on this pub-get and this library will be downloaded and added inside our project in just a minute. And there you can see this library is downloaded and it is now added inside our Flutter project. And after adding the library, open the documentation page again and go to readme section. And there we will find the instructions for using this library inside iOS and Android. And you can also see we can use this library inside macOS, web, Windows and Linux as well. So here scroll down and the first section which you are going to find is for iOS. So basically to use this library inside our iOS applications, we need to follow these steps. And if we want to use this library inside Android, then we need to follow these instructions as well. So these are some additional things which we need to do for Android and iOS. So we are firstly going to start by looking at the instructions for iOS. So as the main purpose of this library is to open the gallery so that user can select an image. And similarly it also provides an option to launch the camera so that user can capture an image. So for using this library we need to add few permissions inside our application. So basically we are going to show user a dialog that our application want to access the gallery or the camera. And if user will gonna allow those permissions, only then this library will gonna help us to choose or capture images inside Flutter. So to add those permissions, we need to add some key string pairs inside our iOS section. So basically when you will gonna open the Flutter project, you will find this iOS folder. And when you will expand it, you will find this runner folder, so expand it. And inside it, you will find this info.plist file. So now inside this file, we need to specify the reason that why our application want to access the gallery or camera. And we are going to specify that reason in the form of this key string pair. So between these key pairs, we need to specify the key that for which permission we are writing the reason in the string tag. So here when you will open the documentation page, the first tag is this ns photo library usage description. And here we need to specify the reason that why our application want to access this photo library. So just simply copy this key and open our application. And here inside this dictionary tag, add a new key tag. And after that paste the line that we copied and then create a closing key tag as well. So here we have specified this key, and now to write the reason you are going to add a string tag here, and after that create a closing string tag as well. And now between these string tags you need to write the reason that why your application want to access the gallery, and this reason will be according to your application. Like if you are building an image editing application, then you can write the reason as my application provides the functionality to edit images, so that's why we need to access the gallery. So here you can type that reason. And after that we need to do the same thing for the camera as well. So what you can do is to copy this key string tag and then you can paste it here. and after that improve the spacing, and then open the documentation page and copy this NS camera usage description, and after that open our application again, and here in the key tag simply replace the key with this key. So now here you will going to write the reason that why your application want to access the camera. And similarly, if inside your application you want to record a video, then you need to specify the reason that why your application want to access the microphone as well. So that's how inside iOS section you are going to specify the permissions. So after following these steps, the setup for iOS is completed. And now the next instructions are for Android. So for Android, no configuration required. So as this library is updated, so now we don't need to do anything inside Android section. And by just simply installing this library inside our Flutter project, we can use it inside Android applications as well. So after doing that, the setup for both Android and iOS is completed. And now the next step is using this library for choosing or capturing images inside Flutter. So now after setting up the library, let's start using it for choosing or capturing images. So on this documentation page, scroll down and you will find this example section, and there you will gonna find the instructions for using this library inside Flutter. So you can see the first step is creating an image picker object. And after that, to pick an image, they are calling this picker.pickImage method, and inside it they are specifying the source to gallery. So basically if you want to select the image from gallery, then specify the source to gallery here, and if you want to capture an image using camera, then specify the source to camera here. So now let's start using this library so that things will be clear. So first step is creating this image picker object. So open our application and go to main ... and here we can remove these comments to make our code cleaner. Similarly, let's remove all of these comments as well. And after doing that, to format our code, right click or press Ctrl click and select this reformat code with dot format, and it will gonna format our code, and it is looking much better. So now let's enhance this section, and then above our build method we are going to declare an image picker object. So let's call this object as image picker, and after that add a late keyword before this declaration because we want to declare it later. So after declaring the object here, we are going to initialize it inside our init state method. So here type init and you will see this option for init state. So just select it and this method will be added. So this init state method is the first method which will be called once our application will be visible on screen, and inside it we are going to initialize this image picker. So write image picker and then call its constructor, so image picker, and that's it. So now we are declaring our image picker object here and initializing it inside our init state. And after doing that, we need to use this image picker for choosing or capturing image. So to do that, we are going to create a method and name it choosEmage. And we are going to call this method when we want to choose an image from gallery. And as we want to choose the image when the user will gonna click on this button, so we are going to call this method inside this onPress. So call this choosEmage method here, and that's it. So now when the user will gonna click on this button, this choosEmage method will be executed, and inside it we are going to write the code for launching the gallery and choosing the image. So to do that, we are going to use this image picker and we are going to call its pickImage method, and inside it we need to specify the image source. So type image source and then add a dot, and you will see these two sources here. So as we want to choose image from gallery, so we will select gallery here, and that's it. So this line will gonna open the gallery once user will gonna click on this button, and then user can select the image, and once user will gonna select it, this pickImage will gonna return an X file object. So here we can create an X file object, and then we can name it selected image, and after that we can assign the result here, And as this X file is nullable, so add a question mark here, and after that we need to add an await keyword here. And we have added this await keyword here because this pick image method will gonna open the gallery, and until user will gonna select the image, we are not going to get this X file. So basically we need to wait here. So that's why we added this keyword, and once we will do that, we need to make the method asynchronous inside which we are calling this await keyword. So make this method asynchronous, and that's it. So it means that this method will be executed asynchronously, and meanwhile other things can be performed in the backend. So now this choose image method will be called, and inside it we are calling this pick image, and it will gonna show a gallery here. And once user will gonna select the image, we are going to get that image in the form of X file object. And after getting the image, we need to display that image to the user on screen. And to do that, we need to store this X file inside our file variable. Because when this image variable will not be null, then this image will be displayed on screen using this image.file. So here, to convert this X file into a file object, you can firstly check that if the selected image is null or not, because there are chances that it will be null because it is nullable. So if it is not null, so in that case we are going to assign the result to our image variable, and here we are going to create a new file object, and inside it we are going to pass the path of the file, and we are going to get the path using our selected image. So selected image dot path, and after that add a semicolon, and that's it. So basically if the user have selected the image, then this code will be executed, and we are going to store that selected image in the form of file object inside our image variable. And now as this image variable will not be null and it is containing an image, so our image will be displayed here instead of this icon. But to tell our GUI that this image variable is changed, we need to call setState method, and inside it pass the variable about which you want to inform the GUI, and that's it. So now as this image variable will not be null, and because of this setState our GUI will be updated, so we will be able to see the selected image here. So after making all of these changes, simply click on the stop main dot and then install the application again inside the simulator. And now you will be able to choose images inside our Flutter application. Similarly, you can install it inside an Android emulator, and you can perform the same thing there. And here you can notice that we clicked on the stop main dot and then install the application again, and the reason is we have added the image picker library, and now to make those changes in the installed application we need to install it completely. So now our application is installed, so let's click on this button. And there you can see when I clicked on it, I got this pop-up that our application would like to access your photos. And the reason mentioned here is the word which we put inside our info.playlist. So there you can see we did not write any proper reason. We just wrote the word reason. So whatever text you will gonna write here, it will be visible. So here let's give this permission. And once I did that, I will be able to see the gallery of my iPhone. And same will be the case for Android. And here we can select any image, like I am going to select this image. And as soon as I selected the image, our image is being displayed in the GUI. And the reason for this thing is, once user have selected the image, we got that image in the form of X file object, and then we converted it into a file object and told our GUI that this image variable is updated. And now in the GUI we are checking the value of this image variable. So if it is not null, then we are going to display the image using this image widget. Similarly, you can try the same thing for some other image. So I will gonna select this image, and you can see our image is being displayed here. So now the first feature of our image picker application is working correctly. If you want to become a mobile machine learning expert, then subscribe to this channel and check out our mobile machine learning courses available on Udemy. The discounted coupons are given in the description. And now after choosing the image, the next step is capturing the images using camera inside our application. So to do that, what we need to do is to add another callback inside this elevated button. So basically we want that when the user will gonna long press on this button, we want to open the camera so that user can capture an image. So inside our elevated button, after this on press, we can add an on long press method, and then we can create the body of this method. And now inside these brackets we can call another method which is capture image. And we did not created this method yet, but now above we are going to create this method below this choose image. So simply copy this choose image method and paste it below, and here rename it to capture image. And after doing that, inside this method we need to make only one change, and that is instead of this image source to gallery, we need to specify the image source to camera here, and that's it. So now when the user will gonna long press on this method, then this capture image method will be called, and inside it we are using this image picker.pick image method, but this time this pick image will gonna launch the camera, and once user will gonna capture the image, we are showing that image to the user on screen. But if you will try to run the application on iOS simulator, you will not going to get anything upon long pressing on this button, because there is no camera preview inside iOS simulator. So to test this feature, we need to install the application inside an Android emulator. So to test this feature, I am going to install this application on an Android emulator. So I will gonna select this Pixel 8 emulator here, and in your case you can select the one which you created. And after that, let's simply click on this run main dot dot, and our application will be installed inside that emulator in just a minute. So now the application is installed inside this Android emulator, and because of the settings of my system you can see this warning, so I can click on wait and this will be gone, but in your case it will not gonna occur. So to open the camera, what we can do is to long press on this choose or capture button, and there you can see the camera is opened inside this Android emulator, and this is the default camera preview for this emulator. So let's capture an image. And once I capture the image, you can see this captured image is being displayed inside our application. And same is the case for real device, that when you are going to install this application inside your real iOS or Android device, you will be able to choose or capture images inside your application. And we are doing that with the help of this image picker package. Welcome to this lecture. So now we have completed our image picker application in Flutter, and in this application we are choosing images from gallery or capturing them using camera inside Flutter. And in this lecture we will quickly review the process that how we have built this application. So firstly, we have created a new Flutter project, and then in that project we have added this image picker library, and using this library we are able to choose or capture images inside Flutter. And after adding the library, we have specified the permissions for iOS inside our info.plist file. And after doing that, inside our main dot dot, we have declared an image picker object, and then we initialized it inside our init set. After that, in the GUI, we have added this elevated button, and when the user is clicking on it, we are calling this choose image method, and when the user is long pressing on it, we are calling this capture image method. And inside these methods, we are using this image picker library to choose or capture images. So here, once user will gonna capture the image or he will gonna choose it, we are going to get that image in the form of X file object, and after that we are converting it into a file object, and then we are storing it inside this image variable, and we are using this image variable in the GUI to display the image. So there you can see we are checking the value of this image variable, that if it is not null, then we are going to display the image stored inside this variable. So that is the reason that once user will gonna choose or capture the image, the selected image is being displayed here. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Flutter and face recognition course. The complete course is around 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 50 students. And now let's continue to the next lecture. So now let's start building our face recognition with images application. And for that purpose, the first step is getting our starter application code from GitHub. Or you will also find the starter application code in this lecture resources. So you can simply download it and open it inside Android Studio. But in our case, we are going to open this repository and you will also find its link in this lecture resources. And once it is opened, you can click on this code button and then copy this link. After that, open your Android Studio and here click on this get from version control. Now paste the link here and then you can select your project location and then finally click clone and our starter application will be cloned in just a minute. And there you can see our starter application is imported successfully. So let's firstly install this application inside an Android emulator or inside an iOS emulator to see what does this application contain. And after that we are going to start performing face detection and face recognition inside our application. So to do that, I can go to device manager and there I can launch an Android emulator. So you can see in my running device section I already got it running here. And after that I will gonna select it here and then install our application inside it. Similarly, if you are using a Mac, you can try to install this application inside an iOS simulator. And this application which we are going to build will be fully compatible with iOS. And we will try to even test it inside iOS at the end of this section. So there you can see our application is installed and that is the GUI of our starter application. So this is the home screen and here we got 3 buttons. So first one is register face, then recognize face and then this registered faces. So this register face is used to register a new face inside our application. And this recognize face is used to recognize registered faces. And this registered faces button is used to see the list of already registered faces. And when you will click on this register face button, you can notice this screen is opened. And inside this screen we got the code of our image picker application. The only difference is now we got this beautiful looking GUI. But apart from that, the functionality is exactly same. So it means that in this screen you can either choose image from gallery or capture image using camera. And after that our selected or captured image will be displayed here. So let's try that. So I will gonna choose an image from gallery. And there you can see our selected image is being displayed here beautifully. Similarly, you can also capture an image. So this is the current working or current functionality of this screen. And now we are going to add the code inside this application screen for performing face detection and face recognition. Similarly, if you will move back and open this recognize face, here you will find the exactly same GUI and same functionality. So this is our starter application code where we currently got the code for choosing or capturing images using camera. And now we are going to add the code for performing face detection and face recognition. So after looking at the working of this starter application, let's quickly look at the code. So I will expand this lib folder and you can notice now we got 4 dot files here. So firstly we got this main dot file and right now in this main dot we are simply opening our home screen. So this home screen has this particular GUI. So when you will open this home screen dot dot, there you will find the GUI for this home screen. So you will firstly find this build method, and inside it you can notice we got a scaffold, and then inside this scaffold we are firstly setting this beautiful green gradient in the background. So there you can see the code for that thing. And after that we got a column widget, and there we are firstly displaying the text face ID app. So there you can see this text here, and below that we are displaying this text secure, fast and accurate, and then we are displaying our logo. So this logo.png is this image which we are displaying here, and inside our project we have added this images folder, and there we have added this logo.png. And after adding this images folder here inside our pubspec.yaml file, we have also declared this folder. So there you can notice that. So after looking at the image, the next thing is these buttons, and we are adding them here. So you can see we are calling this app button widget, and there we are passing the label, the icon and the onPress method. So basically in order to create these buttons, we have created this stateless widget here, and this widget is creating the GUI for these buttons. So you can notice that in the build method of this widget we got this elevated button, and then we are displaying the text and the icon inside it, and this text and icon will be passed by user in the parameters. So here firstly for register button we are passing the label to register face, and then this face add icon, and after that we are setting this onPress listener that when user will gonna click on this register face button, we are going to open this registration screen dot dot. After that you can see we got our recognize face button, and there we are opening our recognition screen dot dot. And then we got our registered faces button, and for now we are not opening any screen here, but later we are going to create this registered faces screen and open it when user will gonna click on this button. So this is the code for this home screen. And now let's look at our registration screen. So this screen will be opened once user will gonna click on this registered face button. So let's click on it. And there you can see this screen is opened. And now to look at its GUI, you can go to the build method, and there you can see firstly again we are displaying our background gradient, and after that the text face registration, and then to display our image beautifully we got this container here. So in this container we got this clip or rect widget. So this is for creating a rounded rectangle, and then inside it we are displaying our selected or captured image using our image widget. And if user have not selected the image, so in that case we are displaying our logo.png. And then below that we are creating two buttons. So firstly this gallery button and then this camera button, and to create them we are using this method here. So inside this method we got the code for creating these buttons, and here you can notice that once user will gonna click on this gallery button, we are going to call this image from gallery method, and once he will gonna click on the camera button, we are going to call this image from camera, and we got these methods above. So there you can see the same image from gallery and camera methods which we have used inside our image picker application. So above we have declared and initialized our image picker, and then inside these methods we are capturing images or choosing images inside these methods. And once user will gonna choose or capture the image, we are storing the image in this image variable, and then we are calling this do face detection method, and inside this method we are going to write the code for performing face detection. So right now we are not doing any such thing. So this is the code for this face registration screen, and we got the exact same code inside this recognition screen. So there is no difference except this face registration will be changed to face recognition. So this is the code of our starter application, and here for performing or choosing or capturing images inside our pubspec.yaml file, you can notice we have added this image picker library. So that's why we are able to choose or capture images, and we got two more libraries here and we are going to use them in future. But for now we have imported our starter application code and see it's working, and then we have quickly covered the code of this starter application as well. If you want to become a mobile machine learning expert, then subscribe to this channel and check out our mobile machine learning courses available on Udemy. The discounted coupons are given in the description. So now after importing our starter application, the next thing is performing face detection. So basically we want to register faces inside this face registration screen, and for that purpose when user will gonna choose or capture the image, then firstly we are going to detect faces present in that image, and after that we are going to crop those detected faces and pass them to our face recognition model and register them. So to do this whole process, the first step is detecting faces present in the image, and for that purpose we are going to use face detection models of Google ML Kit. So to use or perform face detection inside our Flutter application, you can open your browser and go to pub.dev. So here type pub.dev and press enter. So this is a site where we will find Flutter and Dart packages, and the package which we are looking for is face detection. So type face detection here and press enter. And there you can see the first result is this Google ML Kit face detection. So this is a library provided by Google which can efficiently detect faces, and we are going to use it. And to do that, click on it and its documentation will be opened. And here the first step is adding this library inside our Flutter project. And to do that, you can simply copy this dependency and then open our project. And here inside pubspec.yaml file below this path provider, we are going to paste it. After that, click on this pubget so that the library will be downloaded and added inside our project. And there you can see the library is imported and added inside our project successfully. So after adding the library, open the documentation page again, and here the next step is looking at the setup for Android and iOS. But before that, let's look at the documentation of this feature a little. And to do that, you can click on this Google ML Kit face detection link, and it will gonna open Google developer site. And there you can see the detail about this feature of Google ML Kit. So with Google ML Kit face detection library, you can detect faces in an image, identify key facial features, and also get the contours. So to understand its feature better, you can scroll down and you will find this example image. So if we are going to pass this image to face detection model of Google ML Kit, then we can get the location of face present in the image. But apart from that, we will get the location of different facial landmarks as well. Like we can get the position of eyes, nose, cheeks, lips, and so on. And apart from the location or position of these landmarks, we will get the contours, and these contours are actually the list of points which are covering that particular landmark. Like in case of eyes, we will get the list of these points, and when we are going to join them, we will get the exact position of the eye. Similarly, these are the contours for the face as well. And apart from these landmarks and the rectangle, we will also get few other things as well, and you will find them here. So you can notice that the first feature is getting face landmark, and then the second one is getting the face contours, which are the list of points which create the shape of different landmark. And then the third thing is recognizing facial expression. So it means that using this library we can also detect whether that person's face is smiling one or serious. Similarly, we can also detect whether the eyes are open or closed. And after that, the next feature is we can track faces. So it means that the library will gonna assign a unique ID to each face, and using that ID we can track that face in case of live camera footage. And then the last feature is use of this library with live camera footage, and we are also going to do that while building our real-time face recognition application. So this is a little introduction of face detection library, and now the next step is using it inside our application. And to do that, the first thing is we need to do the setup for Android, and then the second thing is setup for iOS. So for Android we need to make sure these three things. So our minimum SDK version should be 21, and our target and compile SDK versions should be 35 or greater. And to check them, you can go to your project and expand this Android folder. Then inside app you will open this build.gradle file, and there you will find this min SDK, target SDK, and then this compile SDK. So after adding the library, if you will try to run it inside Android and you will get some error like try to increase your SDK versions, then you can manually specify 35 here and then 35 here, and after that specify 21 here, and then try to run the app, and the app will run successfully. So this is a setup for Android, and we can try that. So let's close our application and then install it again, and if we got any error while installing it, then we are going to make the change here. But I am not doing it because by default our min SDK version is greater than or equal to 21, and this target and compile SDK version is also greater than 35. But if in your case, if you are getting the error, you can do that. So now let's wait for this application to be installed. And there you can see our application is installed again, so it means that the library is added successfully. And now the next thing is doing the setup for iOS. So after doing the setup for both Android and iOS, it's time to use this library, and we are going to use it inside our face registration screen. So here in this screen, once user will gonna choose image from gallery or capture image using camera, then we are saving the image in a file format and calling this do face detection. So here we need to pass that image to our face detection model and get the detected face. And to do that, you will find a usage section here. So there you can see the first step is creating an input image. So basically we want to pass our selected or captured image to our face detection model, but we cannot pass that image directly to our face detection model. We need to firstly convert that image into an input image format, and then we can pass that particular image to our model. So to do that, what we can do is to convert our image from a file format to an input image format. So here you can declare an input image object, so input image, and this class is actually present inside our face detection library. So here firstly we need to import this library. So you see this option of importing this Google MLKit face detection library, and then we can name it like input image. And after that, to convert our image from a file format into this input image format, we can use this input image dot from file function, and here we can pass our underscore image. So basically this particular function of this class can convert a file into that input image format. So when this line will be executed, our selected or captured image will be converted into this format. And now we can pass this input image to our face detection model. But before that, we need to declare and initialize our face detector. So to do that, you will find these lines here. So simply copy them and then go to our init state, and there you can see this section for initializing our face detector. So let's paste it here, and after that let's look at it. So here we are firstly creating a face detector option object, and by using this option object we can customize our face detector, and we are going to cover that detail in just a second. But after that we are initializing our face detector model using this constructor. So when this line will be executed, our face detection model will be initialized, or our face detector will be created. And now to this face detector we can pass our image and detect faces. But before that we need to declare this face detector above so that we can access it outside of this init state. And to do that, above we can use late face detector, and then we can name it as face detector. And after that we can remove this final from here, and that's it. So basically we are declaring our face detector here and then initializing it inside our init state. So once this init state will be executed, our face detection model will be loaded. And now to this face detection model we can pass this input image. And to do that you can write the code here by yourself, or you can also copy it from here. So to pass our image to a face detector model, we can use our face detector and call its process image method, and there you can see this method is taking an input image as a parameter, and then it is returning list of face as output. So it means that this process image method will gonna pass our image to a face detection model and then return the list of faces present in the image. So here let's pass our input image here, and then to get the results we can create a list of face and name it faces. And then as this process image will gonna take some time, so we are going to add an await keyword here, and that's it. So basically once we are going to pass our image to this process image method, it will gonna pass it to our model and return the list of detected faces. And then to confirm that whether our application is working correctly at this point, we can try to print the detail of detected faces in the console. And to do that you will find some code here. So you can see we got this for loop where we are iterating the list of detected faces. So simply copy it and then paste it here. And then we are going to remove a lot of code from here, but before that let's quickly look at it. So let's suppose we have passed an image which contains 3 faces, and we got this list of faces which got 3 face objects. So now here we are iterating this list of faces, and for each face we are accessing the bounding box. So this is actually a rectangle specifying that where in the image face is present. And after that for each detected face we can get the head angle, and this information is used to align person head. And after that if you want to get the location for individual landmarks, like you can get the location of left ear, right ear and so on, you can do that using this landmark property. And then here you can specify the landmark type for which you want to get the information. And if you will remove the dot from here and add it again, you can see the list of landmarks. So you can get left cheek, left ear, left eye, mouth, base, cheek, ear, eye, mouth and so on. And after that you can see if you want to check whether that person is smiling or not, then you will get this smiling probability. So if this value is not null, then you can get it here, and then you can check if this value is close to 1, then it means that person is smiling, otherwise person is serious. And the same way you can also get the eye open probability. So there you can see the left eye open, the right eye open probabilities. And then finally you can also get the tracking ID for the face. But here you should consider one thing, and that is you will be able to get all of these things if you have enabled them while creating your face detector. So there you can see we have this face detector option object, and this option object is used to customize our face detection model. So here you can see we can pass different parameters to enable or disable certain features. Like if you want to get the eye open probability or smile probability, then you should enable classification. Like here you can type enable classification and pass true. Similarly, now to use other features, you need to enable that feature here. But right now we are not going to cover further detail about it, but maybe later. So what we can do is to remove all this extra information, and then we can try to print the location of each face in the console. And to do that, we can use our print function and then add face equal to, and after that we can print our bounding box. So bounding box dot toString, and that's it. So now at this point, if you will try to run your application again and choose an image, then in the console you will be able to get the location of face present in the image, and this will be true only if our face detection model is working. So let's test that. So I will gonna hard restart our application. So our application is restarted. So here let's click on register face and then select an image from gallery. So let's try this one, and there you can see our image is being displayed here. And if we will check this console section, you can see we got this line face equal to, and then we got this rectangle object which is pointing at the location of the face. So it means that our application is working correctly and we are able to perform face detection inside our application. And now after printing the location of this face in the console, the next thing is drawing the rectangle around this face, and we are going to perform it inside our next lecture. So see you in the next lecture. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Flutter and face recognition course. The complete course is around 5 hours long, and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below, and we are offering a discount to first 50 students. And now let's continue to the next lecture. So now after passing our image to a face detection model and then printing the location of face in the console, it's time to draw a rectangle around this face. So basically this will gonna give you an idea that our face location which is being detected is accurate or not. And then later, while performing face recognition, we are also going to display the name of the recognized face along with the rectangle on the image. So now our next task is drawing the rectangles around detected faces, and to do that we are going to start the process. So right now you can notice that we are displaying our image simply using this image widget. But now on that image we want to draw a rectangle, and to achieve that we cannot simply use this simple image widget, but instead we need a widget where we can firstly draw our image, and then on that image we can draw a rectangle. And one such widget in Flutter is called custom paint. So custom paint widget is such widget where we will get a canvas, and then on that canvas we can draw anything. So in our case, on that canvas we are firstly going to draw our image, and then at the location of face we are going to draw the rectangle. And to do that we got some code commented here. So what you can do is to simply move this commented code to a new line and then uncomment it. And after that we can comment the line where we are displaying our image using an image widget. And now you can see there is no error here, but we got a lot of errors here. And to resolve them, what you can do is to firstly scroll to the bottom and you will find our custom painter class here. So what you can do is to select this whole class and uncomment it. So here basically we got a custom painter class, and this class is used to draw anything on canvas. So in our case we got this face painter which is extending this custom painter, and when we extend this custom painter class then we get this paint method, and in this method we get a canvas object. And then on this canvas we can draw anything. Like in our case we are firstly drawing our image on this canvas first, and after that we are using the list of faces, and this is the same list of faces returned by face detection model, and we are drawing a rectangle on the canvas at the location of face. So at this point these things will be confusing for you, but these things will be cleared once we will proceed in this lecture. So right now we have created this face painter class which is extending custom painter, and to this class we are going to pass the list of detected faces and our image, and this class will gonna draw the image on the canvas first, and then it will gonna draw the rectangles on the image, and we are using this face painter class here inside our GUI. So you can see here we are using this custom paint, and inside it we are using our face painter. So inside this custom paint widget we need to specify a painter, and that painter must be a class which is extending custom painter, so that's why we created it. And then to this class we are passing our list of detected faces and our image, but we did not declare this list of faces outside of our do face detection, so let's simply do that. So here we are going to declare this list of faces above, and then let's initialize it as well with a simple list, and then we are going to remove this declaration from here. And now if you will scroll down, you can see the error related to this faces is gone, and the only error which we got is for this image variable. So there you can notice we are not using our underscore image, which is our image in a file format here, but instead we are using this image variable, and the reason is we want to draw that image on our custom paint widget, and we cannot simply use our image in the form of file. So to draw an image on this custom painter, we are going to convert it into a format called image. So this thing might be confusing for you, but in order to draw our image on a canvas, we are going to convert our image into a specific format, and that format is provided by this image library. So you can notice that we have added this image library inside our pub spec. So this is a specific library for converting our images into a particular format so that we can perform a lot of operations on them. And one of the features of this library is the image provided by this library can be drawn on our custom painter. So now the next step is converting our image from a file format into that particular image format, and we can do that inside our do face detection, or after this do face detection we can create a new method, and there we are going to convert our image from this file format to that particular image format. So let's create a new method, draw rectangles around faces. And then inside this method we are going to write the code for converting this image file into that particular format. So let's also call this method, so draw rectangle around faces. So by calling this method here, we are making sure that once we are going to perform face detection and now we want to draw the rectangles, then we are going to convert our image so that we can draw the rectangle and the image on custom painter. And now here the main task is to convert this image from a file format into that image format. And to do that, we can firstly declare that image variable above. And in that variable we are going to store our converted image, and then the next step is taking our image and getting the bytes for it. And to do that you can use this read as bytes method, and then we can add a not null insertion here. And after that, in order to store these bytes, we can create a variable and name it bytes. And as this read as bytes will gonna take some time to be executed or return the bytes, then we can add an await keyword here. And after that, to perform or add the await keyword here, we need to make our method async. So here we can add async keyword. And that's it. So basically inside this method we are firstly getting the bytes for our image file. So now after getting the bytes for this image, the next thing is converting it into that image format. And for that purpose we can use that image variable here. And then to convert these bytes into that image format, we can use a method called decode image from list. So there you can see this method. And now inside this method we are going to pass our bytes, and this method will also gonna take some time, so we can add an await keyword here. So now when these two lines will be executed, our image will be converted from a file format to this image format. And then to update our GUI we can call set state and pass our image here and also our faces list here. So now by doing this, we are making sure that once face detection will be performed and then our image will be converted into this image format, then we want to update the GUI and display or update our custom painter. And there if you will scroll down, you will gonna notice that all the errors are gone as well. So now after making these changes, let's firstly test our application, and then we are going to understand this custom painter related thing further. So I will gonna quickly hard restart our application. So there you can see our application is hard restarted. So let's go to register face, and there let's select the image again. And there you can see our image is visible, but apart from that a rectangle is drawn around the face. So it means that our application is working correctly and we are able to draw the rectangles around detected faces. Similarly, if you are going to select an image which contain like 5 persons, you will gonna notice that the rectangle will be drawn around each of the face. So now after doing that, inside our next lecture we are going to cover this rectangle drawing related thing or this custom painter related thing in detail. But right now we are able to draw the rectangles around detected faces. If you want to become a mobile machine learning expert, then subscribe to this channel and check out our mobile machine learning courses available on Udemy. The discounted coupons are given in the description. So now after drawing the rectangles around detected faces, let's look at our custom painter related code again. So as I told you that custom paint is such widget on which we can draw anything, and in our case we wanted to draw the rectangles around detected faces, and for that purpose we have passed our list of detected faces and our image to our custom painter class. So we got this class here. And there you can see it is extending custom painter, and then we are getting these two things, and when we are extending this custom painter we get this paint method, and in this method we will get this canvas. And now on this canvas we can draw anything, and the thing which we are going to draw on this canvas, it will be visible inside our GUI where we are using that custom paint widget. So in our case on this canvas we are firstly drawing our image. So there you can see canvas.draw image, and then we are passing our image file. So on this canvas the first thing which will be drawn is our image, and after that we are going to draw the rectangles, and for that purpose we are iterating this list of faces here, and then for each face we are accessing the bounding box. And to draw this rectangle or bounding box on the canvas, we are using this canvas.drawRect function, and here we are passing the detected rectangle, and then the second thing is a paint object. So this paint object is used to customize our rectangle. So here you can see we created this paint object, and then we are selecting the color of this rectangle to red, and then the style to stroke, and after that we are selecting the stroke width to 3. So it means that that by using this paint object, we are specifying that our rectangle will be red and it will only gonna have a stroke or a border and it will not be filled. And then the stroke width or the border width will be 3. And then we are passing that paint object here. And if you will change this red to light green, then you will get a green rectangle here and so on. So now here for each detected face, this code will be executed and rectangle will be drawn on the canvas. So that's how we are able to draw the rectangles around detected faces. And now let's quickly review the process. So at this point inside this application, user can choose or capture the image. And once he will gonna choose or capture the image, we are going to pass that image to our face detection model and get the list of faces. And then we are converting our image from a file format into this image format and updating our GUI where we are using this custom paint widget. And this custom paint widget will gonna refresh this face painter, and there we are firstly drawing the image on the canvas and then the rectangles on the image around the faces. So now after performing face detection and then drawing the rectangle around detected face, the next step is performing face recognition. And for that purpose, we are going to crop the face from this image and pass it to our face recognition model. So our next big thing is cropping this face from this original image. And to do that, we are going to use the results of face detection model. So as you know, face detection is giving us the location of each face present in the image. So by using that information, we can crop the face from the original image. And to crop our image or crop the face from the original image, we are going to firstly convert this image into a format provided by this image library. So there you can see we have added this library inside our pubspec.yaml, and this library is used for image manipulation. Like in our case, we want to crop our image, so that's why we are going to use this library. And earlier when we were drawing the rectangle on the image, there by mistake I mentioned that we are converting our image from a file format into an image format provided by this image library. But instead here we are converting our image from file format into a format provided by this painting library. So inside our previous lecture, that was the mistake I made. But now here we are going to convert our image from this file format into a format provided by that image library. And to do that, we are firstly going to access our image in a file format, so underscore image, and we are going to get its bytes. So to get the bytes directly, we can use this read as byte sync, and then we can assign the result to our bytes variable. And then here we can add a not null insertion. So now after getting the bytes, the next step is converting our image into that image format provided by this library. And to do that, if you will scroll up, you will gonna notice that in the import section, we are importing that image library with the alias img. So it means that now wherever we want to use an image format provided by this library, we can use this shortcut or alias. So I will gonna use it here to declare an image variable. So img.image, and then here we are going to name it like temp image. And after that, we are going to use a method present in this library, and that is decode image. And then here we can specify our bytes. And then here we need to make this image as nullable because this method can also return null. So now when this line will be executed, our image will be converted from this file format into a format provided by this library. And now here we can easily crop this image by using a method provided by this library. So we can use this img, and then you will find a method called copy crop. So this method will gonna take a source image which will be in this particular format, and then we need to specify the x and y points from where we need to start cropping, and then the width and the height. So here we can specify this temp image, and we can add normal insertion, and then we need to specify the X point, that from which point we need to crop the image. So here what we can do is to use this bounding box or face rect to get this X point, but we are not going to do that yet. So instead we are firstly going to assign the result to a new variable. So we can name this variable as face image, and then assign the result of copy crop to it. And after that add a semicolon here and then specify these values. So to crop the face we are going to use the rectangle which contains the location of the face. So here to specify the X point we can use this face rect dot left, and as it's a double so we need to convert it into an integer because this copy crop will gonna take integer values. And then we need to specify the Y point, and we can get it using top. So paste it here and change this left with top. And after that we need to specify the width and the height of face, and we can do that by using the width property. So face rect dot width and face rect dot height. And that's it. So now when these lines will be executed, our image will be converted into this format, and then we are cropping a portion of image where the face is present. And now we need to pass this face or cropped image to our face recognition model and get the face embedding. And then we are going to register or recognize the face. But now here we can confirm that whether the correct portion of the image is being cropped or not by simply displaying this cropped face or face image inside our GUI. So to do that, what you can do is to declare this face image outside. So here after this image we can declare this face image, and then we can assign the value inside this method. And after that inside our GUI we can make some temporary changes. So it means that we are going to remove these changes at the end of this lecture, and those changes are, we are going to check the value of face image here instead of this image. So add a condition that if it is not null, so in that case we are going to display that face image inside our GUI. So what we can do is to simply comment this section for now, and after that we can write the code to display our image which is stored inside this face image variable. But we cannot display this face image just like this image variable or this image widget, but instead we have to use our image widget and use its memory function. And then here we need to specify the bytes of this face image. And to get the bytes of this face image we are going to use this uint8list class and then its from list function. And then inside it we can use this img.encodepng method. And then here we can specify our face image. And that's it. So now here we are firstly encoding this image into PNG, and then we are getting the bytes for it and passing it to this memory function. And after doing this, above inside our draw rectangle around faces method, we are going to add this face image inside the set state. And the reason is, once we are going to convert or crop the face from the original image, then once this draw rectangle around face will be executed, we want to update the GUI where we are using this face image variable. And remember, these are just temporary changes to see the cropped face, and we are going to remove them in just a minute. So here we are going to quickly restart our application. So there you can see our application is restarted. So let's select the same image. So we are going to select this one. And there you can see this time only our cropped face is visible. Similarly, let's try another one. So we are going to select this image. And there you can see our cropped image is visible. And after that we can use this one. And there you can see only the cropped face is visible. So it means that cropping the face successfully here. So now after making sure that our image is being cropped successfully, let's undo some changes in the GUI. So what we can do is to comment this line because we are not going to display our cropped face. And we are going to uncomment this section because we are going to display our whole image with a rectangle drawn around the face. And then here we can also remove this face image. And that's it. So now after doing that, let's restart our application to make sure that our complete image is visible and the rectangle is drawn around the face or not. And there you can see we got the complete image here and the rectangle is also being drawn. And now starting from our next lecture, we are going to start the process of face recognition. So see you in the next lecture. Hello guys, Hamza here. I just want to let you know that this video is just the first part of my complete Flutter and face recognition course. The complete course is around 5 hours long and it includes all source code that we write in this course. Every section has before and after source code, so you can easily code along with me. Apart from that, you will get a certificate upon completion which you can add to your resume. And the course comes with a 30 days money back guarantee. So if you are not satisfied, just simply ask for a refund. So if you are interested, I will put a link down below and we are offering a discount to first 50 students. And now let's continue to the next lecture.